Alright, so we're kind of backtracking. Earlier we were looking at 2-5, and now we're going to go back to chapter 1 for a little bit as we go back over distance and the distance formula. So here is our warm-up, covering what we just covered in the previous unit. How many lines are in plane Z? You can see line ATB there, and we also have line L also in plane Z, so we have two lines in plane Z. What is another name for line AB? That is going to be using any 2 points on that same line as A and B are. So we can just go backwards and do BA. There's a lot of different options for this one since we have 3 points on that line. So we just do AT if we wanted to. That would work as well. There's one. Lots of different names though. Could do BA, TA, you do BT or TB. Up to you. That's really pretty much it. I've listed them all out. But naming a line in plane Z. Again, we already said there are 2 lines in plane Z. The only 2 lines we can see are in plane Z, and the line we just named is in plane Z. We also have line L in plane Z. Naming the intersection of planes Z and W. So that is, again, line AT, or AB, or TA, or BA, whatever you want to call it. And the last part, naming 3 collinear points, so 3 points all on the same line. That only happens with line AT, which means A, T, and B are 3 points. So today, we also did vocab this day. So if you didn't already, hopefully you defined all those words. I'm not going to accept those words at this point, but you can try and define them just so you have them. Line segment, distance, irrational number, betweenness of points, between, congruent, rigid transformation, congruent segments, construction. These are all words we're going to look at today. And the first one's between. So again, that's one of our vocab words. So you should have defined it weeks ago. So we're going to jump through that real quick. Point M is between points P and Q if and only if P, Q, and M are collinear and PM plus MQ is equal to PQ. So here we have a line with a point in between, and we want to find XZ, so the length of XZ. So what we need to do here is just add these fractions together. Good old addition of fractions. And they are mixed numbers, so we need to get rid of that first. So, first thing, to get rid of the 4 and 5/8, we multiply 4 times 8. It's 32. 32 plus 5 is 37 over 8. Plus, and 2 1/2. 2 times 2 is 4. 4 plus 1 is 5. It's 5 halves. Now we need a common denominator. And that common denominator is 8. So the 37/8 stays the same. And to get the other one to be an 8, we multiply 2 times 4 to get 8. So 5 times 4 is 20. Now we just add across the top. It's 57 over 8. And that comes out to be, now we want to turn it into a mixed number. So 57, 8 goes into 57 7 times. And there's 1/8 left over. And that's our answer. Our next one, same concept, but now we have variables involved, and we are given how long the entire line is. It's SU, which is the entire thing. It's 45. So we just need to take 5x minus 3. That's a terrible looking x. Minus 3 plus the 7x, and set that equal to 45. So now you combine like terms. You have 5x plus 7x, so that's going to be 12x. Minus 3 equal to 45. Then we add 3 to both sides. And 12x is equal to 48. Then we just divide by 12. X is 4. We just wanted to find x, so we're done. Here's some information involving congruent segments. So if we know congruent segments have the same measure, then that symbol there with the squiggly over the equal sign is read as congruent to. And then red slashes on the figure also indicate congruence, so you can see in the picture they both have a little pink line that tells us that they are congruent. So then we have the distance formula on a number line. We just have to use an absolute value sign and just subtract the difference between the 2 points. That's what we're going to use first for this one problem here. So if you don't know, absolute value just kind of solves for the distance, or the gap between. So here we have the distance between -6 and -3. So the absolute value of -6 minus negative, so we turn it to +3. This is our distance. So d is equal to the absolute value of -3. So d is just equal to 3. And we don't have a unit because they are just on a number line. Fairly simple. Basically, whatever you have in the absolute value sign, you just get rid of the sign and you're good. So now the distance formula on a coordinate plane. So if you're given 2 coordinates, you can use this to find the distance between the 2 coordinates. And that's what we'll do. We'll do it twice. Do a couple of these. This first one just gives us the points -4, 1, and 3, -1. So using the formula we just looked at, which is a play off of the Pythagorean theorem, by the way. So you're squaring the x values, or squaring the distance that the x values changed, then you're squaring the distance that the y values changed, and you're adding them together and you're square rooting. So you're solving for your hypotenuse. That's what we're doing here. So d is equal to the square root our x values, so -4 minus 3 squared plus our y values, 1 and -1. So 1 minus -1 turns positive, and we square that. So now we're equal to the square root -4 minus 3 is -7, plus 1 plus 1 is 2, and -7 squared is 49, and 2 squared is 4. So we end up with the square root of 53, which is about, so when you have 2 squiggly lines, that's approximately, or about, and that is almost equal to 7.28. And since we're just looking at the coordinate plane, we don't have a unit here either, so that's our distance. You can leave it as the square root of 53. Depends on the question. If it's multiple choice, it's asking for the decimal, or the answers are all decimals, then obviously you want to find the decimal. So this next one is a real world problem. So we have these 2 guys on a football field. Josh throws the ball to Johnny, makes this little triangle. So now we need to use our distance formula. So you notice that Johnny's at 85, right? 80, and this is x value 5. The reason it's 80 is because Josh is on the other side of the field. That's a 30. So 30 to 50 is 20, and then the other, well, 20. Okay, sorry. So he's at the 80 yards away from the end zone, which is our 1-1. So we have 50 yards and then another 30 to get him to the 20-yard line. So let's use our distance formula we just used. So d is the square root of 80 minus 30 squared. You can start with the other number. You can do 30 minus 80 if you want. You're going to end up with a negative on one of these. So it's going to be 5 minus 15. Just got to make sure you put the signs right, but really it doesn't matter as much because we are going to square them in this case. 80 minus 30 is 50. And 5 minus 15 is a negative 10. 50 squared is 2,500. And 100, negative 10 squared is 100. So we're looking at the square root of 2,600 yards. Or approximately, when you punch this in the calculator, you get 50.99 yards. So either one of these works as an answer. And that's it. Here's our exit ticket. Ben is standing on the 40-yard line, so it's exactly the same problem, just different positions on the field. Ben is standing on the 40-yard line, 20 yards from the sideline, and when he throws the football, Eric catches it on the other sideline, other team's 30-yard line, 10 yards from the same sideline. And how far did he throw it? So keep in mind, if he's on the other team's 30, going from the end zone to the 30, it's going to be 50 plus 20, so he's at 70 yards away. So Ben is at 40, Eric is at 70. So our points would be 40, 20, and 70, 10. And you just plug those into the formula like we just did.